Hello class, today we're going to talk about two lines cut by a transversal. So the first thing that we're going to do is fold two lines that are not parallel but that don't intersect on the patty paper. Two lines that are not parallel are called skew lines. So just fold wherever you want and fold all the way across the patty paper. And then I'm going to fold somewhere else so that they're not parallel and that they would intersect somewhere off the patty paper. Now I'm going to trace these so I can see them better using a straight edge. I'm going to label these lines L and M. When I label lines that way, I use a script letter. Now I'm going to fold to create a third line that intersects both these lines, but is not perpendicular to them. I shall trace that, and I'm going to label it T for transversal. This is called the transversal. I'm going to label the angles as well. Make sure you label them the same way that I did so that we don't get confused when we're talking about things. Now, what relationships are present in this top set of angles? All right, so we saw that there are vertical angles, the angles that are opposite each other, 2 and 4 and 1 and 3, and then we have the linear pairs, 1 and 2, 2 and 3, 3 and 4, and 1 and 4. Those same relationships are present in the bottom 4 angles. But is the top set related to the bottom set? I'm going to check by tracing. I'm going to trace the lines up here, and then I'm going to slide or translate these 4 angles down the transversal and see if they match up with the angles on the bottom line. And I see that no, the top angles are not congruent to the bottom angles because they did not translate and map to those bottom angles. However, though these sets aren't congruent to each other, we do have words to describe their position relative to each other. So what you're going to do now is paste this patty paper into your notes, and we will locate and take note of the interior, exterior, same side, alternate side, and corresponding angles. All right, take out a new piece of patty paper. In the first demonstration, we folded skew lines, lines that were not parallel. Can I use folding to construct a pair of parallel lines? Let's investigate. So start again with any old line crossing the patty paper. I'm going to trace it. Now the first thing I'm going to do is to create a perpendicular to this line by folding it. I'm going to fold it more or less in half, though I don't have to fold it in half. I just have to fold it so that the line coincides with itself. Now when I open it up, I can check and say, okay, is this in fact perpendicular? And I can check with the corner of my patty paper, and yes, it does appear to be. Now, I am going to choose a point on the perpendicular, which I should trace. I'm put a point anywhere on this perpendicular that I want my parallel line to pass through. So can anybody tell me what to do next? All right, so what I'm going to do now is fold this perpendicular line onto itself so that the fold passes through the point that I chose. So two things are happening. I'm folding it onto itself and the fold's going through that point there. Now I'm going to trace that line. I'm going to label these lines L and M. And again, I'm going to label this transversal T. So these appear to be parallel. L and M appear to be parallel to each other. But how do I know that these lines are parallel? Can you explain why? All right, if two lines, L and M, are both perpendicular to a third line, T, then the lines are parallel. Let's paste this diagram into our notebook and add the marking and geometric notation. We'll work on that on the smartboard. In our next investigation, we will construct a pair of parallel lines and draw in a non-perpendicular transversal and then make conjectures about how the different positions we learned about relate to one another. So let's repeat the construction that we did before to create parallel lines. I start with any line. I fold it onto itself to create a perpendicular line. I'm not going to trace it this time. And then I put a point somewhere on that perpendicular fold, and I fold it onto the perpendicular onto itself such that the crease passes through that point. I didn't trace the perpendicular on purpose. So I know these lines are parallel because they're perpendicular to this third line. But now let's say I draw in a transversal that is not perpendicular. I'm going to label this L, M, and T again. Now, how does the top set of angles relate to the bottom set of angles? In our first investigation, we saw that they weren't congruent. But now that we have a transversal passing through parallel lines, what is true? So I'm going to trace these top angles, and I'm going to slide them down, and I can see now that these angles, when I translate them down, map perfectly onto the bottom set of angles. So I'm going to conclude that the top angles are congruent to the bottom angles. Let's use some color to make these relationships pop out on us. I'm confident that these four acute angles are all congruent, so I'm going to color them red. And I'm confident that all four of these obtuse angles are all congruent, so I'm going to color them blue. So we can see that there are many congruent angle pairs. All the angles colored red are congruent to each other, and all those colored blue are congruent. But how does any blue angle relate to any red angle? They are supplementary. All right, so recall that again, that in the first investigation, two lines cut by a transversal, the lines were not parallel and these angles were not congruent to each other. In fact, that's how we can determine if two lines are parallel. If the top set is the same as the bottom set, the lines are parallel. If not, they are skew lines. Now we are going to formalize this understanding using the vocabulary we used earlier or yesterday and some congruence marks. The end.